So just to introduce the speakers real quickly, on the far end there is Jason Cavatorta. He's a plant breeder and owner of a seed company called Earthwork Seed in Florida. And he most recently released the tomato variety Damsel, which is a hybrid tomato with late blight resistance. And he worked with Bill Waycott, sitting next to him from Nipomo Native Seeds, who runs a seed production company in California. And they worked together to kind of pave the way and test if they could economically produce an organic tomato hybrid in this country. And then we're going to move on, and Tom Stearns is going to talk about some of his experiences doing organic cucurbit hybrid production. So Tom is the founder of Mowing Seeds and has started to focus a lot more in the seed production side of the business. And then finally, we're going to move on to Jeffrey Block from Gro Alliance. And he is the, can you remind me of your title there, Jeff?
Organic corn production.
Organic corn production guy. And he is doing some interesting work developing a network of organic seed growers in the Midwest to try to grow the capacity to do more organic hybrid corn production. So with that, I'd like to give it up to Jason to give you a little bit of an introduction to hybrids and how they're produced.
Okay, so we thought it would be a good idea to do just a little general background about hybrid seeds. We talk a lot about seed production here, but not hybrid seed production. And so we just wanted to touch on some of the differences between producing hybrid crops and open pollinated crops. So this is just about 10 or 15 minutes, a little bit of background. So what, why, and how? What is a hybrid? Why do we grow hybrids? And how do you produce the seed of a hybrid crop? The term hybrid is kind of confusing because it has a general meaning, which is just a combination of two different things, like a spoon and a fork, a bat and a boy, or a carrot and a man. And we also say things like hybrid vehicles, but that's not what we're talking about today. We're talking about the biological definition, which is an F1 hybrid. And that F1 stands for the first filial generation, and it's when we cross two plants or animals together from a different species or a different variety. And so this is just a screen grab from Mowing's website, and you can see that that tomato says Iron Lady F1, and that F1 means it's a hybrid. It's important to say that it's kind of the opposite of an open pollinated variety, and it excludes a variety from being an heirloom. So here are some examples in animals, like a labradoodle, or if you cross a horse with a donkey, if the horse is the female, it's a mule. If the donkey is the female, it's called a hinny. And here are some examples of hybrid crops in some different species that might be familiar. Question 2, why? Why would somebody choose to grow a hybrid crop? And I could just kind of come up with 4 main reasons. 1 is hybrid vigor. 2 is to combine different traits into one variety. And 3 is sometimes you want to maintain a gene in the heterozygous state, and having a hybrid crop allows you to do that. And 4, for increased uniformity and stability. And so just real quick, I'd like to go through some examples of why this is important. Hybrid vigor corn is the classic case where you have 2 parental lines and you cross them together and you get this hybrid that's just much higher yielding and more robust. Two, you might want to combine multiple traits. this is important in things like tomatoes, where we have a lot of disease resistance genes that we're breeding together into a hybrid, and it can be very difficult. It'd be very difficult to get all of those resistance genes into the same plant. So you can put half of them into one plant, you can put the other half into another plant, and you can cross them together and get a hybrid that has all of those genes in one variety. You can also take something that's really disease resistant and cross it to something that tastes really good, or maybe is really early, and try to combine those characteristics into a single variety. And sometimes you want to keep a gene in a heterozygous state. So if you want to make a pink flower, sometimes you might have to cross a white flower and a red flower together. And you only get pink if that gene is heterozygous, so you could never stably express that in an open pollinated variety because it would segregate every generation. And the same thing is true like in bicolor in squashes, has to be heterozygous for the precocious B gene. And so you could never make something that looked like Zephyr in an open pollinated variety. You would have some plants that were bicolor and some that were not. Uniformity and stability. So typically with a hybrid, although not always, you cross together two fairly inbred lines to make a hybrid. And that means that those hybrids are all both genetically identical to one another and have a high degree of heterozygosity. And that can give you a product that is very uniform and also very stable across environments. Can you guys all hear me okay? I thought it was important to say why not. There are some reasons to not grow hybrid crops, and I think it's important to just consider them briefly. It costs a lot more to produce seeds of a hybrid, so the seed is more expensive. And of course, if being independent from seed companies and saving your own seed is something that's important to you, you probably don't want to grow a hybrid. Because those seeds, of course, will not breed true. So if you save seed off of a hybrid, the seed will not be the same as the parent. So how are hybrids produced? It's very similar to producing seeds in other ways, except for two things. You have to grow two parents out, and you have to make sure first that parent one does not pollinate itself. And then you have to take pollen from parent two and bring it on to parent one. And then the seed that you harvest off of parent one will be hybrid seed. There are several techniques for kind of doing this, and it depends a little bit on the floral biology of the crop. And so we're going to talk about several examples today that are a little bit different, but basically the same basic technique, which is we're preventing something from pollinating itself, and then we're bringing in pollen from another line. So there's a couple ways to prevent something from pollinating itself. Typically, you have to remove the pollen-producing parts of that plant, and that can be done manually by hand, or sometimes with, if it's a really small flower, you might have to get in there with tweezers to do it. If it's something like squash, you can just break those flowers off. And you can use there are some chemicals that you can use that cause male flowers to, that basically chemically emasculates those plants, although those are not allowed in organic production. And then there are genetic techniques to prevent a plant from pollinating itself, such as male sterility, and that can be either nuclear male sterility or cytoplasmic male sterility. You can use self-incompatibility, where a plant produces pollen, but it cannot pollinate itself. Or gynoeci and dioeci, where there are particular plants that do not produce pollen-producing flowers. Now let's give a quick example. This is a picture of male sterility in carrots. And so there's a great story about Henry Munger is the breeder in the upper right. And the story I heard was that he was blueberry picking with his wife, and Cape Cod, and maybe someone can tell me if I'm wrong. Okay, blackberry. Thank you. And he saw he saw a wildflower, Queen Anne's lace, which is a wild carrot that looked a little bit weird, and it had this male sterility. He went out and expected it closer, and he saw that it was not producing any pollen. And I believe that's called the brown anther male sterility in carrots. I mean, it's crazy because like someone he was, first of all, he noticed that, but then he actually dug this plant up and he brought it back to his greenhouse in Cornell, and he propagated that plant and crossed it to a carrot, and he bred this male sterility source into carrots, and it's used in virtually all carrot hybrid seed production. And so you can see that here's a picture where there's, in the center there are some plants that do not produce pollen, and they're being used as the seed parent. And then the ones with the white flowers are producing pollen, and so all the seed harvested off of the male sterile plant will be hybrid. Self-incompatibility is commonly used in brassicas, and this is where the plant will, let me see if this works. So a plant, a broccoli flower will produce pollen, and if that pollen lands onto a flower on the same broccoli line, there's a gene called the self-incompatibility gene that will prevent that pollen from growing a pollen tube and fertilizing the eggs in the flower. So you will not get pollination. So pollen will land on the flower, but it won't successfully pollinate within that line. If pollen from another broccoli line came over, then it would successfully pollinate. And there's two types of self-incompatibility. There's gametophytic self-incompatibility, where this recognition happens kind of lower down on the flower. And this is I believe tomatillos have gametophytic self-incompatibility, and then there's sporophytic in brassicas. And so you can use this to do a hybrid seed production because that plant will not pollinate itself. And then some plants, either like in cucumbers, there are two types of flowers. Well, there's a gene that controls gynoece in cucumbers, and the plant will only make female flowers, so you don't have to worry about it pollinating itself. And then there are some dioecious crops like asparagus that make genetically male and genetically female plants. So you can find plants that are female and will not pollinate themselves. Okay, and then now we know how to make a plant not pollinate itself. So how do you bring pollen over from the second parent? Well, it's very similar to how it's done if you're doing an open pollinated production. And if it's an outcrossing species like corn or squash, either wind or pollinators can bring that pollen over onto the plants that you're using as the seed parent. If it's a self-pollinating crop like tomatoes, you actually have to go in there by hand and take the pollen over and pollinate it onto the other parent. And so crops like tomatoes are very labor intensive. Okay, that's the background. Sorry to get a little bit scientific. So the first case study we're going to talk about is tomatoes. And so this is a picture of damsel tomato, which is a tomato that I bred to be late blight resistant. It's a pink slicer. I came to this conference. Let's see, is that the next slide? I came to this conference 2 years ago with this variety that I had in mind, and I was looking for a seed grower. I did not know if I could find somebody who would grow this seed for me. And I went to a talk that Sebastian gave and was blown away by all the really cool seed productions that he was doing. And I went to several other talks. Nobody was doing tomato productions. And so I guess I have a couple questions for you guys. Who grows hybrid tomatoes? I mean, who in this room grows hybrid tomatoes? Just for on their garden or on their farm? Okay. What varieties do you guys grow of hybrid? Damsel. Good answer. Tokita. But Tokita bred it. Where did the seeds, where did they actually come from? I mean, that was what question I had, and I didn't really know. And yeah, that was a question. That was a question that I wanted to find out. And I was kind of surprised what I learned. I mean, there's nobody in the United States producing hybrid tomato seeds. So I came here trying to find a seed grower, and there was nobody. And I work with a lot of organic farmers who are super passionate about locally produced food. And I heard all this stuff at the Organic Seed Alliance about how important it is to build a local seed system. And everybody is growing hybrid seeds that are grown overseas, and people don't even know it. And think about how frustrating you guys are selling produce when you're trying to sell produce to people and they're buying it from Salinas Valley in New England, and you want to jump up and down and say, no, like you should buy this lettuce that was grown down the road. Well, I want to say the same thing to you guys about seeds. And even at a place like here, where everyone is so focused on seed, is something that we don't talk about and no one really knows all that much about. Yes, please. Okay, so where was I going to grow this tomato seed? To really find out, we have to take a field trip, and we're going to take a field trip. I hope you guys will indulge me for about 5 minutes, and we're going to go to China. Okay, it's just background elevator music, so we don't need it. And I'm going to put it on 2x, so it goes a little bit faster. It's going to take about 5 minutes. But this is in northwest China, this is a tomato seed production. And this was put on YouTube by a company, I'm not even sure who. They sent this young guy, we'll see him in some of the pictures on his vacation, to document how the tomato seeds were produced for their business. And there's no sound, so if you guys want to talk or ask questions, we could do that at the same time.
So Jason, China is now currently.
I can't find any information. I don't know what % come from China. I know a lot do in Thailand, and that includes organic seed. Here's the mill outside. They'll collect the pollen off of. Yeah, these are dried flowers. They're putting them into a little bowl here, and they're going to shake it and get the pollen out. They're smoking cigarettes, so they're sure to get TMV infection everywhere. This is kind of cool. They put them in these like straws, the pollen, and they carry those out with them. To produce seed this way, it costs a company about 0.3 or 0.5 cents a seed.
So both parents are outside?
I think they have in this case they are both outside. Yep, it's done outside. I don't know if they're always done that way. And yeah, here they are. So like we talked about, hand emasculation, they're removing the anthers from the flowers. and then they're coming back through with those straws of pollen and pollinating the flowers.
Yeah.
They remove the sepals so that when they're harvesting the fruit, they can double check that it was a pollination because the sepals will be removed. He's on vacation. I wish I knew who this guy was. There it is. They look to make sure there's only 2 sepals on the fruit.
Do you know, is this a certified organic?
I don't know. Probably not. Probably not. Yeah. And like Erwin said, I mean, the reason it's done here is because minimum wage in China is like 82 cents an hour.
Maybe Bill's going to get to this, but they didn't do any type of bagging or closing up that pollinated. So how fast does the pollen move through the pollen tube that they're not worried about any other contamination?
I don't know, but generally, I believe people don't worry about pollination in tomato flowers after hand pollination.
Where did we do all of our greenhouses? So there's no
Seed fermentation. Okay, and now they dry the seed. I don't know if we need to see every step of the way, but you guys kind of get the point. This is the vision of the Organic Seed Alliance, and to produce organic tomato seed, I did not want to go to China, and so I found Bill.
Awesome, Jason. Awesome. That was great. Well, my agricultural experience started in the Peace Corps in 1974 in Karnataka, India. I was a city boy, and I ended up on a farm in rural India and fell in love with agriculture. So I just wanted to say that before we got started. Let's see, I think, is this it? Here. Most of my life I've been working on leafy green vegetables, with lettuce being the main vegetable, but many others as well. And I was just minding my business, and Jason and I happened to create a friendship when we worked for the previous employer. And when we both left, we started talking to each other and making just a chance to communicate and share ideas. And we came to the seed conference here 2 years ago, and I heard his frustration. Well, one of the things in working in agriculture, and especially agricultural research, is you know how to manipulate things and get things done. So we live in Nipomo, California, which is located here on the south central coast of California, between San Luis Obispo and Santa Maria. And we have a 10-acre farm on the Nipomo Mesa. And I grew tomatoes there the first year we started, which has now been 3.5 years ago. And I noticed that other than the occasional horn earworm, tomatoes were absolutely clean. There was no disease, there was no pest. It was almost as if we were working in a sterile environment. It was just incredible. And I mentioned this to Jason, and I said, you know, I think we can grow tomatoes for seed here. It just seems like the climate is ideal. It may be a little bit cool, but eventually the fruit will form and we'll make a good product. So we put our farm together. At that point, we now have a good series of greenhouses that are available, as well as open field. And I have a team that I'm working with, that I worked with before when we worked at the company, and now working together here on the farm. So once we got the idea to produce tomatoes, I got going immediately, and that was before we even had our first greenhouse up. So we started our work in the shadow of the skeleton of the first greenhouse that we constructed. We didn't want to waste any time, and we knew that we could start it in the summertime, and by, let's say, October or so, in our climate, we would still be okay, not having had a frost at that point, and hopefully have the top on. So literally, we were pollinating and building at the same time. This was about 2.5 years ago. Planting our males in one series and our females in another, extracting pollen, and getting the job done. Finally, put the roof on of the first house, and that was a real accomplishment. All of these were put together by ourselves. We just bought the pieces from a manufacturer and built everything ourselves. And now we're moving right along with both, mainly the hand-pollinated hybrids. We're doing tomatoes, we're doing several in the cucurbits, and investigating other options as well. The thing is that we are doing it organically, so it's been a challenge to keep things clean and healthy, since we're using products that we weren't used to in commercial, conventional agriculture. Figured out how to extract pollen. We figured out how to emasculate very quickly and produce materials that we needed to. As you know, many of you know, tomato flowers are a selfing flower, so the pollen producing organ is encircles the female. And so in the emasculation process, we simply come in just before the flower opens, gently remove the petals and the pollen cone, which circles the female there. You can see it in the center. And then what you're left with is what's down in the next slide at the bottom, with an exposed pistil and the sepals. And we put ourselves to work, and this is damsel that we've harvested 1.5 years ago for Jason, and it did quite well. The extraction is a straightforward process. We cut the fruit in two and then remove it from the skin. But one of the things we noticed early on was we were getting these big, beautiful fruits, and there were very few seeds in them. So we had to kind of go back to the drawing board and figure out what was going on there. It turns out that the pollination timing is very important. And we've been able, fortunately, to bring things back up to normal through trying different pollination schedules as we moved forward. So that's one thing that was a bit frustrating, and Jason got several calls from me complaining that I could. They sure taste good, but there are no seeds in them. That's not to say we didn't have some issues in doing this. The promise of a completely clean tomato plant outdoors does not work in a closed environment, unfortunately. And so, as many of you know, we create these microenvironments that can put a lot of things out of whack. And some of those is the predators that we're feeding on, the aphids and the psyllids and the mites and whatnot are not present. So we have to remedy that. Another issue, of course, is blossom end rot in a high humidity, high heat environment can create an issue too. So we did have our share of these pests and diseases. Fortunately, through using organic means, mainly the the soaps and things like that, we were able to control the soft body insects. And with the mites using sulfur, we were able to do that as well. And the viruses, we just have to make sure to keep the thrips out as best we can. And with the blossom end rot, we learned how to irrigate in a fashion that would avoid that problem. For sort of the bottom line of my presentation, and this is what I'd like to share with you, and that is that out of the total expense, we came up with about 32% of the total gross income was spent on labor. So that would be the darker greens section here, and our input costs were about 9%. So we're running at about, say, 41% of the total gross income that came in was used up in producing the seed. So to answer your question, can it be done in the United States? It can. It's not an extremely profitable proposition, but with refinement, I think it can be easily done. And there's no reason why we can't produce hybrid seed here in this country. Jason?
Yeah, I just wanted to say at the end that, okay, so Bill produced this seed, and these are the retailers that are selling it. And some retailers preferred to have conventional seed for a cheaper price, and so I did a production in Costa Rica as well. And both are available, and these are the retailers who chose to buy the more expensive organic seed, and I thought that was worth putting up here. So you guys can hopefully support them. I don't exactly know, but we estimated this year that there'll be over 10,000 people who buy the seed that Bill produced in his greenhouse.
Okay, the first question was storing pollen. I'm not an expert in that area. I know that it is possible. Tomato pollen is not, does not senesce, if you would, immediately, like in some of the other species. So we would often harvest the pollen the evening before and then put it in the refrigerator and then use it the next morning. I don't know, Jason, you probably know, I wouldn't take it too much farther than that, 24 hours, something like that. Sure, yeah. The second question was exerting the female part. It's not a problem. Well, if you can properly emasculate, it's clearly visible, and you can work with it. Yeah, no, the construction of the flower is that it's completely enclosed in a pollen-bearing organ, and it's risky business. Yeah, I got pretty good at it. 15 seconds, maybe. Yeah. Yeah. So the cone is very good at holding the pollen in itself, and there's a very small opening, and so you kind of have to tease it out. And we used several different methods, and we found that the vibrating, not the brush itself, but just the actual physical part of the toothbrush that holds the bristles, when put up next to it at the right time. I mean, and you can only do it maybe once, and maybe get 1.5 harvests to fully harvest the pollen from the male. You have to hit it right at the right time, and that vibration helps a lot. Yeah.
And Bill and I met because we were both plant breeders at Monsanto. So I find it kind of funny and maybe a little ironic that it took two ex-Monsanto guys to do organic hybrid tomato seed production. That's awesome. But yeah, it's awesome. I don't have any slides, so we can leave this up, I guess.
Okay, so I'm not a plant breeder, but I really love growing seeds. So I'm going to talk about what we've done with cucurbit seed production, focusing on winter squash. There's a lot of different types of cucurbits, and Bill and I have exchanged notes on melon, hybrid melon seed production, which he's done some for us, and different methods of doing that. We did our melon seed production, hybrid melon seed production this year by emasculating. Bill did his by hand pollinating. We shared all of our notes of all of our results and labor and yields, and I like his method better. So we're going to try that this year, and then we'll send our notes back over and we'll see how it goes. A little Vermont, California competition here. But winter squash, we don't need to get into the flowers in any way like with tomatoes with winter squash. You've got separate male flowers and female flowers. So I'm just going to describe the process briefly because Jason covered it already, and then just talk about some of the requirements for a male line and requirements for a female line to make sure that to optimize the seed production efficiency and yield. And I'm happy to share all kinds of numbers about our labor, our costs, and everything else, so that both from the perspective of United States production, as well as seed growers who might be thinking about what sort of profit per acre they might be able to make doing hybrid seed production instead of, or along with OP production. One question or one response that I had, and Frank, I think it was your question about the comparative yield between hybrid tomato seed and open pollinated tomato seed. We've done hybrid tomato seed production also on our farm, and the yield difference that I've seen is it's about a quarter of the yield of open pollinated production. When you have a flower cluster with 3, 4, 5 flowers on it, and you're pollinating a few of those for hybrids, you often take the rest of those flowers off, so that all the energy in that cluster is going to the 1 or 2 on that cluster that were ready that day that you pollinated. And so you automatically reduce the yield there, but I'm not sure if that really translates in every situation, but a little bit. Okay, so as Jason was saying, you've got your female line of squash, and think of it just like a row. Here's your row of female plants, and you just need to make sure that the male flowers on those plants are not going to pollinate the female flowers on those plants and create a self line. So the main process is emasculating those plants, where you go through and you take all of those male flowers off. And so if you think about a squash, you know, there's the male flower can be fairly large when it's open like this, but you can still tell which flowers are male and which ones are female when they are very, very small, like the tip of your pinky small, you can tell. And so it's important to get as many male flowers as you can so that you don't have the risk of an escaped male that opens up, or you don't have to be going through on such a regular basis. So I'll talk a little bit about the mechanics of that. Then the male line, all you need from the male line besides the genetics in this case is the pollen. And so you need to manage that male line and the production of that male line for pollen. Now the breeding of that male line has to consider a whole lot of other traits, and it's a whole other story about if in your breeding you're only paying attention to the male as a source of pollen, you're going to end up in trouble down the road when you're trying to do this organically. And in many cases, that's why hybrid brassica seed production organically is so tricky when the variety was bred for a conventional system. So with squash and with that male line as a pollen source, the timing is extremely essential. In the case of tomatoes, you've got a crop that is kind of continually flowering. Squash do the same thing, but it's not as much of a window. You have longer time to mature the fruit afterwards. And then with corn, as we'll hear, there is only one shot, 1 week period when the silks are receptive and the pollen is available. So it's narrower there. In the case of squash, though, we plant the male plants at twice the density of the female plants. So we make sure to have a lot of pollen production. We don't need them to make fruit, so we don't really care what they do after they make their flowers, their male flowers. And so far, in most of the lines that we've got, we're planting the male line and the female line at the same time. There was a situation when we were producing a hybrid that was just really tricky, and I felt like I should have planted the male line 2 weeks earlier so that those plants were really robust and making a lot of flowers. Ideally, when we do the first emasculation of the female line, I want to have at least 10 open male flowers per plant, so that there's just a real abundance of pollen there. When we were first doing hybrid seed production of squash 10 years ago, we started emasculating the female line as soon as she started producing flowers. And what we now do is we wait probably 2 weeks after that point, so that the female plant is big, it's already setting fruit, and it's making maybe it's got 3 to 5 female flowers on it the day that we emasculate it. Of course, if it has fruit already set, you don't know who those were pollinated by, so you're stripping all of the fruit that were set on it as well, and kind of setting the whole thing back to 0, if that makes sense. If you do it too early, then this female plant is only going to produce 1 more female flower in a couple days, and then 5 days later another female flower, and 5 days later another female flower. And in order to narrow the amount of time, the window of time that you are having controlled pollination, you want it to be able to set as many female fruit as possible right in that narrow window. So in most cases, we are emasculating when the plants are the female line is about 2 months old. So maybe 3 to 4 weeks of growing the seedling, and then another 3 or 4 weeks of it growing out in the field. And at that point, we are sometimes stripping off as many as 4 fruit that have already set, and ideally having 3 to 5 female flowers that will open within the next 7 days. That's the target that we use. So you're checking your crop, and you finally feel like you've got the right timing. You also need to look at the weather. Where we are in Vermont, rainy weather and rain-filled flowers they abort. So you won't have pollen available for the bees to take around. The female flowers will abort. It won't work. So you have to also manage the timing based on the weather and the stage of the plant. The final thing that's important is thinking about who's going to be doing this pollination. And so my favorite thing to do is to have a beautiful field of early planted Phacelia or some other pollinator attractor that is really abundant amount of pollinators surrounding my squash field. And the day before we pollinate, mowing all the Phacelia down, so that now the only thing that's in the field for them to pollinate is the female squash lines and grabbing the pollen from the male lines. But it's like all of a sudden there's like 1,000 people at the ice cream stand when it shuts down. They're gonna go to the place that's right next door to get ice cream. So this has worked well. It seems mean, but it does work really well. We also bring in bees the day before. And so it's kind of a combination of the insects that are already there and then the honeybees we bring in. So, okay, so you're checking the weather, you're managing your pollinators and what's going on, and you're looking at your female line to see when she's large enough to be able to set a bunch of fruit in the next narrow window, and when your male line also has 10 open male flowers per plant. So it's a lot of this sort of dance of managing all these different moving parts, but it's really, really worth it. When you're going through and emasculating and you're picking off all these little male flowers and big male flowers and things like that from your female line, it's also really valuable to pick off all of the growth points except one. So depending on the type of squash and the particular female line, there's almost always multiple growth points, unless it's like a zucchini or something. Each of those growth points is just a pain in your ass because they are sources of more male flowers that you do not need. And generally, you're not going to get a good female fruit set off of those smaller growth points. You just want this one primary growth point, let the plant put most of its energy into that. And you do not want small little growth points at the bottom sneaking out because there's males in there that you won't be able to find, and only if it's too late sometimes. So you go through and you strip all of the male flowers off, and that's sort of day one. And the clock is now ticking. Every day that you are controlling pollination means that you need to be paying close attention to that female line to make sure there are not any escaped males that you missed in the process. So just for example, our beds are 480 feet long, and the female lines are planted every 2 feet. So you have 240 female plants in that line. It takes us 5 hours to do the first emasculation through that. So that is a lot. That's 2 minutes per plant or something like that. So that's day one. Then day two, you do a scan. Make sure you didn't miss anything. We do those scans in the evening because the flowers open the next morning. And so we want to catch any escaped males before they actually open, because then I'll tell you what we have to do and it's no fun. So every single day you're doing this controlled pollination, you are scanning the female rows to make sure there's no escaped males. What you're also doing is checking to see these small males that you didn't miss the first time. They were never there, but there's a new wave of them coming. And you may need to get that next wave also if you haven't set enough fruit during that first window. Those scans take about 10 minutes per bed. So again, 480-foot bed. 5 hours to do the first emasculation, 10 minutes for the daily scan. If you find an escaped flower, an escaped male flower, what we do is we remove all the female fruit adjacent within 3 or 4 plants to that one escaped male flower, because it's at least most likely that any bee that maybe happened to visit there pollinated something that was open and a female fruit next to it. So we're just reducing our likelihood of having a self. And so if each of those fruit is $5 worth of seed or $10 worth of seed, then you can pretty quickly get up to $500 worth of loss for every escaped male flower. So that 10 minutes per bed of daily scanning is really important. And that means Sunday, that means every day. So that's pretty key. A squash plant can set 6 or 8 or even 10 fruit, but it can't carry 8 or 10 fruit all the way to maturity. So if you know your female line well, you'll know, is this one capable of producing 3 plants to maturity, or 5 fruit to maturity, or 5 or 10? And where is realistic to stop this process and mark the fruit that have been set? We are starting to do all of our hybrids with drip tape now, so that we can really manage the water much better. Generally where we are, we don't need to irrigate very much. But I think managing this female lines, it's going to be important to be able to add some fertility if we need to, add some water if we need to, because we had some last year that set 8 fruit all the way to maturity, but the average was 3.4. So what we did is we pollinated an average of 5.2 fruit per plant. And then at the very end, when we harvested, there was 3.4 fruit per plant that made it all the way. So that helps me to know what are the capabilities of this female line, so that I don't have to go all the way to 5 pollinations. I can maybe ratchet it back and stay at just 3 or 4 and assume I'm going to lose 1. Because what you have to do besides these scans is, if you haven't set enough fruit during that window of time, you need to emasculate again. And that's not just a 10-minute scan again. That's more like the 2, 3, 4 hours of going through the whole thing again. the labor can be as much as, 60, 70 hours of labor per week per acre. And so, I mean, we spend like 2 hours, 3 hours for the whole season per acre in weeding. And so you're talking 20 times the amount of time that you would spend cultivating or weeding in managing all this pollination. So the narrower the window, the less labor you have to spend, but you still need to maximize the fruit set in that period of time. So there's a few tips here. Let me make sure I mentioned them all. Male lines produce a lot of male flowers. They need to be vigorous. Female lines, concentrated set of female flowers, high fruit yield and holding. Well, remember also this female line is where your seed is coming from. So any disease that is affecting that is going to not only affect the seed, but also affect the yield of that crop. I really like hybrid seed production with cucurbits because you have such an intimate relationship with the plants. You are right in there, watching it closely and seeing everything on a daily basis, and it's pretty amazing. One experiment we did that I'll mention and then I'll pass it over is when we did a first emasculation, instead of leaving that one remaining growth point, we even removed that one growth point. All little side growth points, all male flowers, and the main growth point. So the only thing that set fruit were the female flowers that were there that day when we did it. And that means that we did not have to come back and look for any males at all. There was no other part of the plant that was making any fruit at all. So it was just like that was all that we could possibly get. What's risky about that is if anything happens to that plant or those growth points or those female flowers, then you can get nothing. But the experiment we did, the labor was potentially 30% less in doing that. So that's an interesting thing. We're going to play with that a little bit more. I won't go into the harvest part of it at all or anything like that. It's just the same as the rest of the harvest. But it's important to note that you need to make sure that you only pick up the right fruit in the field. So we do go through and we mark all of these fruit, but instead of doing it at pollination, like removing some flower parts for the tomatoes, we wait until the fruit have set and until we are no longer doing any more pollination in the whole patch, and we go through with a paintbrush and white paint, and we just splash white paint on all of these fruit throughout it. So when we come back to harvest, that's all that we pick up and harvest. We have, just to give you a sense of costs, for a 480-foot bed, our cost was about $500 a bed of total cost. And that includes land, fertility, plastic, irrigation if we're using it, and all the labor. It's $300 of labor per bed, $500 total. The seed value of that bed is $2,700. We're talking one bed, 480 feet long, and that's wholesaling it to ourselves, not retail. It would be quite a bit more at retail, and that gave us 18 pounds of seed per bed, which is about 88 M. And so this was at a wholesale price of $35 per M per 1,000 seeds. So that's what we sell it to ourselves for. So then when High Mowing, the company, not High Mowing, the farm, marks it up for all of the other costs that we have and things like that, 35 per M is that base price. And so that means that you can net almost 30 grand per acre doing this. So fairly high value crop, but it takes a lot of attention to detail. But it's fun. We would love more people to grow hybrid seed for us. The crops that we did this year on our farm that gave us maybe a 2-year supply of seed were only half-acre crops. So we're not talking about a massive scale. So anyway, I'll leave it at that. Yeah, Erwin? Yeah, the question is about different types of winter squash and how that might be different. So yeah, certainly that's going to be different. The other thing is if your female line is viney, you're screwed. I mean, you're chasing vines all over the place looking for male flowers. Forget it. It is crazy amount. So having the female lines be bushy or at least just a small vine is really important. I mean, I would we have just chopped all of the vines off of female lines as long as there's enough fruit set close by. So that can open up wounds, it takes extra time, and they aren't necessarily bred for a concentrated set. These are both very bushy female parents. So. Okay, so I think we'll leave it there. Thanks.
So my name is Jeff Block. I work for a company called Gro Alliance. We are a contract corn and soybean company. The Gro Alliance is it's a mainstream conventional seed company in the seed industry. I think it's important to talk for a few minutes about the corn seed production industry, because it really, the challenges that we have trying to do corn organically has a lot to do with the industry that it is. So the corn hybrid industry is a large scale industry. Something like 90 million acres of corn are produced in the United States annually. That means that there's somewhere around 550,000 acres of seed corn production going conventionally in the United States. It's an enormous industry. The seed corn growers who are growing seed corn are specialized growers. They use specialized equipment, adjustable rate planters, detasseling machines, cutters, machine pullers, male row destroyers, ear harvest combines, all done on a very large scale. The parent lines for corn, their inbred corn lines, are very high input crop. So this is, in some ways, these parent lines are about as far away from organic agriculture as you can get. They use vast amounts of fertilizer, pesticides, insecticides, fungicides, to try to, you know, to seed corn. I mean, the scale is big. The other aspect of it is once the corn is harvested, it requires a large scale infrastructure to process the seed. The husking beds to husk it, large scale dryers, what we call the conditioning line. The conditioning line is, you know, what we cleaning the seed, sizing the seed, shelling, all that. And then of course the bagging. So this is it's a very massive industry. So the way that the corn industry works, so we are a contract seed producer. We actually produce the seed. So a seed company, okay, back up a step. The corn genetics, the parent lines in the corn industry are all owned by a handful of private companies. Like intellectual property rights are locked down. These companies own the lines. They license them. The way that it works is a seed company, if they want to create a hybrid variety, what they will do is they will get lines from these companies, do test crosses, and decide which hybrid variety they want to grow. And at that point, they'll make a decision about the hybrid, and they will contract with a company like ours, and we will license the seeds from, you know, MBS or Thurston's or Pioneer, get the parent lines, and actually grow out the seed, bag it, clean it, grow it, bag it, and deliver it back to the seed company, and they will sell it. So that is part of the challenge. So yeah, Gro Alliance. So Gro Alliance is this is just a little bit. I mean, the point of Gro Alliance is this is a very conventional seed company. You know, organics is not something that they ever considered or thought about, and the only reason it has been thought about is just because of the place where suddenly organic seed is a thing, and it's going to become a thing. It is actually the largest independent contract corn and soybean in the country. We do work with everybody from basically whoever wants a contract. A lot of multinationals, anybody in the corn business, small companies. It is a family-owned business, you know. It also does soybean production. We do nursery work and trial work as well. So one of the things that makes Gro Alliance a little bit different than a lot of it's actually in the corn industry, it's on a smaller scale. So because of that, there is a lot of, they will take seed contracts that are smaller than everybody else. And the point of this is why Gro Alliance has gotten into the organic market. You know, the company was owned by its third generation, turned over to the younger son, Jim Schweigert, is the company president. He recognized he had the way he told me about it is he was going to ask the seed convention, and people kept asking him if he could produce this variety organically. And since the business model is based on doing smaller lots of seed, he said, why not? Let's give it a try. So that was easier said than done, because the seed growers, the conventional seed growers, because they're at such a large scale, none of them have any interest in transitioning to organics. So what Gro Alliance did was hire a bunch of organic farmers, and then this happened in 2015. They hired a bunch of organic farmers, took their conventional seed corn mentality to these organic farmers, and went and tried to grow it, and they didn't know what to tell the farmers, and the farmers didn't know what to tell Gro Alliance, and it was a complete train wreck. It was an utter disaster. They basically grew fields full of weed that was supposed to be corn. And at that point, that's when they brought me on board, to somebody to try to do a bridge to work with these growers to try to, you know, figure it out how to do it. We're based out of Cuba City, Wisconsin. Gro Alliance actually has a few other sites. I have another grower near Howe, Indiana, but that's our main site. So one of the things that Gro Alliance did when they decided to enter the organic market is they built a dedicated certified organic corn conditioning line, which is, this is what a picture is. That's a picture of, we have seed cleaning equipment, seed sizers, and then a gravity table. There's also a bagging line at the end of it. It's in its own separate building. I think it's the only one that exists in the corn world as an isolated facility. So one of the, what did I just do? Oh, okay, you go ahead. So one of the things that happened when Gro Alliance had that lesson in 2015, when they got spanked and ran away with their tail between their legs, they realized that they couldn't do organic corn like they do conventional corn. And when I got hired, one of the approaches was that if this is going to work, we have to do it the organic way. And so the approach that we're taking with the organic seed corn is that the organic growers come first. We have to use organic methods, working with organic growers, using organic system, and adapting our seed corn equipment to the organic farming. So that's a really important thing, because we're basically using the growers' planters and the growers' equipment, figuring out using the organic growers' cultivation methods and working with them. The whole concept is to be transparent, is to share information, share knowledge. The growers work together, come to places like this and try to build the concept that I am running with this company, is to build an organic hybrid seed corn growers network, figure out how to do it, share our knowledge, get the brain trust going like we all do so well to make this work. Trying to make some private research, public research partnerships. I'm working on some trial stuff with Bill back there at the University of Wisconsin, and I'll get to that in a little bit about some of the stuff we're working on. There's opportunity here for sure. You know, I did, so this year I worked with 7 different growers. We did 500 acres of organic seed corn without really trying to sell it. We're trying to keep it low. We probably could have done 1,000 acres of organic seed corn, but we didn't because it's hard to do. So, so just a little bit about the agronomic aspect. So corn is a wind pollinated crop. The parent plants of corn are a little bit different than the other crops we talk about. They are inbred plants that have been self-downed for multiple generations to have a fixed line. So you have, so they're very wimpy plants to say the least. Anyway, the way that it works is, so the pollen is of course, the tassel, and the female flower is the silk. The way the corn is planted, in most commercial production for us, it's a 4-1 planting pattern where there's 4 rows of female, 1 row of male. For the organic, we're mostly doing a 4-2 planting pattern, mostly because we're using the growers' equipment, which is 6 and 12 row corn planters, basically. And the way that it works is we plant the corn. The females get detasseled before the pollen shed so that just the male pollen comes onto the female silk. One of the tricky things about it is that we often have to do 2 plantings of the male in the same field or in the same row. And the whole reason for that is because oftentimes the male and female corn plants have different maturities and different timings, and trying to hit the timing of when the male pollen is shedding at the same time at the female silk is both crucial and kind of difficult because, you know, maturities just kind of change when you plant things out into the field. So there's often 2 planting dates of the male just to spread out the pollen over a period of time. So I'll get to that in a minute. So one of the big challenges about for seed production, of course, is purity. It's a wind pollinated crop, so we have to have isolation distance, you know. So part of the setting up seed fields for growers is you have to separate it from neighboring corn crops. So we isolate by distance, of course, first of all, but geographical features like woodlots, hills. Take a look at neighboring corn crops. My growers have to talk to the neighbors and try to talk their growers into planting their corn 3 weeks before. You know, please plant your corn on April 30th, and we'll plant our seed crop on May 29th. There's other aspects of seed purity. For example, in the plant itself, for our seed processing, there's very high level of clean out in between crops. It's part of the practices. There's so many different seed lines that go through it that the clean out is down to kernel level in some places to clean out between crops. So one crop that goes to the conditioning line doesn't contaminate the next one. Back to the field stuff, the inbred lines that we get from these genetics companies are sometimes contaminated themselves. So we have to walk the fields and actually rogue out off types off the plants themselves before. This is very important. Like we use our detasseling crew is basically a roguing crew in advance, pulling out off types from these plants. And it's just kind of part of the process for the contamination. Now, you know, and I'm really like, all this is just talking about conventional, really. But we're also trying to do this organically, and everybody in this room knows perfectly well that the purity thing becomes even more important for organics because of the whole GMO issue, you know? And I mean, I don't want to distract this, and the whole GMO thing is that conversation can take up an entire day if we wanted to talk about that. But let's not talk about this thing. Let's try to keep it focused. What I'm trying to do, the approach to the GMO thing is we're just increasing all the practices to as best as we can. The isolation distance for organics is double than that we're doing for conventional. I am very careful about the fields that we're selecting, you know, rejecting fields that just aren't going to work because we have to keep the purity high. We're putting one way that to deal with purity issues is surrounding the fields with male rows of male. So you have male pollen that sheds, you know, and you can kind of screen out the contaminating crops. So extra male rows around the edges. The dedicated organic conditioning building that we have at Gro Alliance, we didn't have to do that. There are other seed companies who are producing organic corn, are using their same conditioning lines that they use for other crop, but it was a tactical decision by Gro Alliance because the business model is based on high quality and pure seed, that this is a place where contamination could happen with transgenic crops. So we keep all our organics isolated in their separate building so that when the seed is harvested from the field through the plant and delivered to the customer, there's not going to be any chance of contamination during that. So, you know, as the producer, that's how we're addressing the GMO thing right now. So to the field, the 2 huge challenges with organic corn is soil fertility and weed control. And it's huge. This is a master level crop for the row crop farmers. The fertility has to be top-notch fertility. Weed control has to be perfect, pretty much. I mentioned the planting of the male hybrid having two. Anybody who knows row crop farming, you know, you plant a male and then you have to go in like 4 days later and plant a second male. In conventional, it's planted 2 inches off the row. You know, all my growers, when you know, none of them grew seed corn, it's like, well, how do I rotary hoe? You know, they need to want to get in there and hoe out the reeds immediately. For weed control, it's an utter challenge to pull that off. I should take a step back. So the inbreds that they're growing, these are totally different plants than corn hybrids. Everybody knows what corn looks like. It's a giant, big thing. The corn inbred plants are this tall. They're each one of my growers, you know, we kind of like when the growers that I've hired to do this sort of thing, you know, I can't call it corn. I wish I had a different name because it's so different than growing corn for these guys. You know, it's growing seed corn. It's about this tall. We have to use untreated seed. The seed itself is not very vigorous, so it doesn't. You have to plant it in warm soil temperatures. We have trouble getting stands sometimes with the inbred seed, doing the untreated seed. It has very poor emergence. It has early vigor problems. It doesn't grow out of the ground. It gets about 2 inches tall and it stops there for like 2 weeks. And the guys who are the new grower come going, oh my God, what's going on with your corn? It's like, don't worry, it's inbred corn. It does that. It'll start growing again someday. It has terrible stress response. Hybrid corn has hybrid vigor. So something will happen to it. There could be damage and it'll grow through it. Inbred corn, when it is stressed by drought or by weed pressure, it doesn't really come back. You know, it affects it, it knocks it back, and it just, you know, it'll go, but it's going to affect the yield. One of the hugest things for the weed control is the fact that it doesn't canopy. There's no canopy. You know, when the growers are growing regular corn, you know, after that last cultivation in July, there could be like little weeds in row, but the corn canopy is covered up. It doesn't grow. The embed corn doesn't canopy most of it. There's full light all the way through. So whatever weeds are left after the last cultivation are going to be huge by August. So those need to be gone. So, anyway, there's just a couple of our inbred fields, some cultivation. That's a pretty nice looking one, but you can kind of see how it doesn't, like this is right before tasseling actually on this one, like not too much farther. So, you know, it's not really going to cover the ground. These are some of the better looking crops for sure. So this last year you know, there's a couple different things about the inbreds. The thing about these conventional inbreds that we're working with is they have been bred for years for conventional agriculture systems, for this high input fertility crops. And so when you take them out of this conventional system and put them in the organic environment, they respond completely different, and in a lot of cases not very good. You know, and the thing is, like, trying to grow corn organically, this is a big gap. It's like part of the disconnect of being the producer and the genetics companies being here, the seed companies being here, and we're producing it. The seed companies do great work. You know, they try out these hybrids under organic conditions, trying to grow the hybrids, but they're not looking at the parent plants for producing the parental inbreds under organic conditions. And this is a huge problem. So I had a situation this year with one of my top growers. This guy's got it down, like 7-year rotations, you know, good fertility. We did 2 seed crops on this farm. Both of them had like 3 years of alfalfa preceding it. One of them was with this female hybrid or inbred that it got about this tall, had big droopy leaves, like it covered the ground really well. The other one over on this side of the farm, the corn got this tall. It had yellow stripes, like to like V3, V4. It was yellow, and it got like this big, you know, at maturity. Excellent weed control in both the fields. The one we set a yield limit. The one like beat that with 55 bushels per acre, which is fantastic for a 4-2 pattern corn. This one got 10 bushels an acre, you know. done the exact same way. So the way that I'm trying to, so this is something that there is nobody doing organic parent producibility. Nobody's looking at it, not anywhere. It's just not happening. So I talked to Bill over here, and we decided to do some trials. I planted a couple trial sets out on Gro Alliance. We did some out on the West Ag Research Farm, you know, and this whole thing about the comparison between conventional organic wasn't the take home. The take home was looking at the organic field and seeing the huge disparity of difference between these parents. You know, there is stuff that was huge and tall, some of these modified females with like great canopy, and then there is stuff that we shouldn't have even had in our organic trial. So we're going to do this again. Like we're going to take this on the Gro Alliance and working with Bill again, and we're going to continue doing this trial. You know, collect seed from these seed companies. I got it from 5 different genetics companies. We're going to expand it this year. We're going to do the trial again. We're planning on doing a field day at the University of Wisconsin in August, and the whole idea of the field day is we want to invite all these genetics companies, all the organic corn companies, some of the top growers, some of the players in the industry like Organic Valley, try to get everybody together and have this conversation about these parents and producing this corn. Because one of the things that I recognize and Gro Alliance recognizes and what we're doing is we're building this industry from scratch. You know, this is a brand new thing that we're building. And unless we get all on the same page and produce corn inbreds that are going to work in organic systems, we're going to shoot ourselves in the foot. You know, it isn't going to work. So anyway, trying to start that conversation in the meta level, try to answer that question. This is a picture, Bill, when was this? August 29th, I think. It's a little, end of August, they laid down a blue thing. How big is that, Bill? That's like 3 foot long or something like that. Yeah. So this was the whole idea to capture this canopy thing I was telling you for weed control. This is corn on August 29th and what the light exposure is like in between the rows on August 29th. So those of you who know corn can see what we're dealing with as far as weed control. You know, there's a, yeah, no, I could run through it. Yeah. So I'm basically done. I have some pictures I could run through about our planting operation. This is just seed planting. You kind of see a little bit in that one. Conventionally it's planted, the first male is planted and the second male is planted 2 inches off. Most of my growers now have GPS and are kind of doing the same thing. That kind of works. Some of them don't have GPS. The ones who don't have GPS, when we plant the second male, we just run right over the row and they, you know, try to make it work. It kind of works. This is just, you know, so like each of my growers have different planters. This guy has a 6-row John Deere regular corn planter. You know, we put the 4 seed things have the female row, the 2 on the outside have the male. We made seed plates that'll do it at half rate. There's another grower. We have, so this is the grower planting the second male. He has you know, is a planter that just has the 4 seed boxes in the part for, you know, the second planting of the male. This particular grower runs GPS, so he's smoking a cigarette probably as he drives. That guy smokes a lot. Seed corn, you can kind of see the 4 rows of females there and the 2 rows of male coming up. We're struggling with stands. Boy, stands is hard with this inbred corn, I tell you. It was another one. We really, really are struggling with stands. Rogaine, you see right there is the off-type hybrid. I mean, one thing about Rogaine is it is inbred corn, so the off-types can be relatively easy to find. They're the big ones. Anything that looks too big, you cut it out, you know. So the outcrosses, yeah. We actually have this pretty cool interactive app thing where I do notes on my phone and we keep track of their inspectors who go in the field. We got to keep careful track of the silken shed. You know, detasseling, timing the detasseling is crucially important in seed corn. detasseling operations. That's a cutter, I think, down there. We run so the way that the tasseling happens is we run this cutter through that, like tops the top of the corn plant. After the cutter is done, we wait 2 days and the tassel kind of extends. And then there's a machine puller, which is basically these wheels that kind of grab the protruding tassel and yank it off. And if we do it right, we've pulled like 85% of the tassels, and then a hand crew runs through and pulls the rest by hand a couple of times. This is some of my organic fields. You can see the one down there with the females detasseled, the males with pollen. There's our our detasseling crew. Harvest. It's done by ear harvest. Try to harvest at 32% moisture or so in the field by ear. Taken by truck to the plant, to the husking. We have these big husking beds down on the bottom there. After it gets husked by the husking beds, which I don't have a picture, so it runs through this conveyor belt. This is a really important part of contamination, because with corn, when it runs down, these people are looking for off types as it runs through the table. They're grabbing out crappy, they're grabbing out garbage, but one of the most important things is with corn, if there is field contamination, they will see it on these tables because it actually looks different. One of the things about it. So this level is very important to get any sort of you can actually pull out, if there is contamination, if this is done right, you can pull out a lot of it at this last stage, you know? So yeah, it goes from there. It's sent to the dryers. This is what a kind of bunch of different lines of organic corn in the dryers. There's one of our dryer facilities. Cleaning line, screen. I'm just going to run through this because we're running out of time. This is our organic corn processing line. We also have a batch seed treater. There are some organic seed treatments that people are starting to use. Whether they work or not, I have no idea. We can argue about that one. Bagging line, sizing. Sizing between the flats and the rounds, the large and the smalls. There you go. That's where they are on the corn plant, if you've ever wondered. Yeah. We have a gravity table. I love the gravity table. I don't know if you've all ever seen a gravity table. Those are just so cool. It basically shakes. It's a table that shakes the plant, and it's tilted, and basically the crappy seed slides all to one side and the heavy seed slides to the other. And it's a little bit of an art, because you kind of you set these little guide things to decide how much of the seed to discard, So it's a cool thing to see. Yeah. Yeah. There's a bunch of our bulk bags full of corn in our warehouse, packaging, bagging. There's our field. That's about it.
I think we're kind of out of time here, but I did want to, I think this is the last session, so I think we could maybe go over a little bit and it would be okay. If you guys need to leave, you certainly can. Jason, did you have a couple wrap-up thoughts that you still wanted to do, or open it up to questions if anybody has any? Yeah, let me.
Yeah, I had a question. There's not a lot of heterosis in squash and tomatoes like in corn. What was the reason for producing hybrids with the squash and tomato varieties that were discussed?
I'm a breeder. Jody is our breeder of those. Actually, she worked with Brent Loy at UNH on those, so I'd have to ask her, but I could follow up with you about it.
Maybe Jason has some thoughts on that.
Yeah, and I've been was talking about that the last couple of days. It would be a lot easier if they were open pollinated. And with the particular tomato we're talking about, it was like a disease resistant tomato crossed to a really good tasting tomato. Could you make one that was open pollinated that had all of those combinations combined? Possibly. And especially in things like squash, where you don't have to combine all these different disease resistances, and there isn't a lot of hybrid vigor, I think you can. And then the question comes to be, can you make a business out of selling something that is easily replicated? And if you were, I mean, I'm spending years and years of my life developing these varieties, and I need to make money by selling seeds. And if a farmer grew carrots and they multiplied in somebody's pantry, there wouldn't be many people growing carrots anymore. So I would like to find a way where I can release good open pollinated varieties and still receive some money for doing that. And so we had, you know, there was a presentation earlier where we talked about some of the examples where that's happening. And I think it is possible. And I'm not, although that variety is hybrid, all of the varieties I'm working on are not hybrid.
Yeah, so I think for the squash, I think a thing about the damsel tomato value I see to start there in a crop I don't work on. I'll comment anyway. But I think one of the key things, uniformity and speed to market. So you can make the hybrid faster, and that can give somebody, you know, we wouldn't have damsel for another few years, right? And it's available now because it's a hybrid. We have some things in, there are some traits, powdery mildew resistance in squash. You tend to get a better crop if it is, you know, not your seed crop, but the one the grower would get if the resistance is heterozygous. It's incompletely dominant, so you get a decent resistance, and you also don't have any yield penalty. There seems to be some linkage drag associated with the resistance. So there are some traits that work best in the hybrid condition. So if you need it to be deployed as heterozygously, then you would want a hybrid. And so I think there's a few reasons. There's also, I think, potential to do stuff with OPs, and you know, so I think case by case, and hybrids are definitely a way to get something cool out now. And if it's for a disease that's affecting the grower, like, yeah, it's great to get it to them right away. I always think that's a great goal.
I want to maybe add one comment to that. And I think that a lot of the resistance to growing hybrids is that farmers are reliant upon breeders to produce the seed of those. And I think it's really interesting that there is a lot of distrust among farmers with the people who are developing their varieties. And there is a hesitant to be reliant on people that you don't really trust. I think that the way that I look at that is farmers are growing the food that we all eat, and we are all very reliant on farmers, and that is not necessarily a bad thing. If you're working with somebody that you trust and they're doing things in a way that you agree with, we should rely on each other. And just like people should vote with their buying decisions about food, you should vote with your buying decisions about seeds. And you should buy the kinds of products that you believe in and you want to support, and you should buy them from the people that you want to give your money to. And if you don't want to buy hybrids, or you don't want to buy from a large multinational company, you shouldn't. And from my perspective, I mean, I'm a plant breeder. That's all I do. I breed plants and I make money by selling seeds. So I'm not a nefarious person, but I am trying to one day, you know, make a living at doing this. And so I do have to figure out a way where I can balance my ideals and make some money. And that's what decisions that farmers face all the time. Like, what do they want to spray on their crops, and who do they want to sell their food to?
So you went from exploring inbred lines to a finished hybrid tomato seed in 2 seasons. Is that right? No.
No.
Okay. How long did it take? How long did that take?
I've been working on damsel for several years before I started my company. Just breeding it. Okay. You know, and basically started working on it in my garden.
Okay.
Yeah.
All right. Well, you didn't do it in 2 years then.
No.
Okay. Well, it's still remarkable how fast you did it. I agree with that. I don't think it's necessarily that we don't trust the producers of hybrid seeds, but if it turns out that the production of the hybrid isn't cost effective, it's going to disappear. That's just economics. And Nelson Carrot is a perfect example. Everybody, the organic community loved Nelson Carrot, and Bayho was going broke producing it. And so the organic growers essentially become really comfortable with a certain hybrid, and then it goes away, and now they have to go through the whole trialing process again to find something that fits that niche. So as long as you're dedicated to your tomato and you don't think that there's more profit in a different tomato, then your relationship with the people buying it is fine. But don't you think that someday you're going to get a better tomato and you're going to drop damsel? And then the people that are used to that are going to go through this withdrawal process again. Okay, that's what I hear from growers whenever a hybrid disappears. It's like, oh, hell, what are we supposed to do now? And that's what all the farmer-to-farmer traffic is out here now. What are you going to, hey, everybody, what are you going to replace Nelson with? And, you know, it's like, oh, well, this one sucks, and this one's a tent peg, and this one doesn't have any flavor, and this one has weak tops, and it goes on and on. So it's not that we don't trust you. We don't trust the economics necessarily, that you will keep doing this as long as somebody could keep producing an OP.
Yeah, I mean, that's not specific to hybrids. There are some good open pollinated varieties that have gone away.
You can always take it over.
If you can find, yes, if you can find some seed of it. Okay. Yeah, and that's true. I mean, I'm continuing to work on tomatoes. I'm not trying to work on Damsel 2 that is like Damsel but has one additional disease resistance, and then I'm going to produce that and then not produce Damsel. And you're right, like the life of that variety is dependent upon how long I want to produce it.
All right, well, I think that probably we should wrap it up now, but I really want to thank our speakers. Bill had to leave a little bit early, but I think this was a really educational and informative talk. I learned a lot myself. I'm sure a lot of you in this room did. These guys were really courageous to tell their stories to this crowd, so please give them an applause.